Good evening, everyone. I'm Calvin Joseph, and today I'll be conducting your problem solving and doubt clearing session for your week 9 for the NPTEL network analysis course. So today we'll be considering how to solve problem where there are dependent voltage sources are present, how to tackle such problems, and what we must consider while solving such circuits. So I'll share my screen. So are you guys able to see my screen?
Yes, sir. Yes, sir.
Okay. So today, this time it is week 9. So we are solving circuits with dependent sources. So does anyone know what do these mean? Anyone has any idea?
Dependent source depend upon the
Dependent source depend on what?
dependent source depend upon the any voltage or current across any branch of an electrical circuit.
Okay. So assume I have a voltage source. So you have a battery. This is your battery, okay? It gives a voltage V. Let us assume it to be 5 volt. So this is an independent voltage source. We consider that this voltage 5 volt will be maintained regardless of whatever circuit is here. Whatever circuit is there, this voltage of 5 volt is maintained by this battery. But suppose we have something like this. This is V, which is given as pi into I1, assume. And this is your circuit. And there is some resistor, and the current flowing through that is I1. Okay. So in this case, the voltage over here is dependent on this current I1 flowing in the circuit. So if your I1 is 0, what will this voltage V be?
V1 is also 0. V is also 0.
Now if your I1 is 10, what will this voltage be?
50 volt.
50 volt. Okay. So has anyone seen any practical dependent source? Or have we studied till now any dependent sources? Any example of a dependent source?
Transistor current.
No, transistors it is there.
Transistor collector current equal alpha times of base current.
Okay, so in a BJT, bipolar junction transistor, your current IC is equal to your current IC is beta times IB. Okay. So for a transistor, this happens. Then, okay, Kavya is saying mutually coupled coil. So what happens in mutually coupled coils?
So current in one coil depends on the coupling factor.
Current
in one coil depends upon the coupling factor, that is mutual inductance in the other coil in between those two.
Okay. Yeah. So first of all, we'll consider for BJT. So this is a BJT, okay. So which is your collector, base and emitter? So this is
The
your
left mode is
left mode is what?
left one is base and the top one is collector and ground is
Down one is emitter.
anything.
So this is NPN or PNP?
NPN
NPN.
transistor.
Okay. Why? Because the arrow is pointing outside. So it is NPN. Okay. So it is a 3-terminal device. So this is your current IC, this is your current IE, and this is your current IB. Okay. So if you draw the small signal model of this, you will get this is your B, and there is some resistance R5. This is your emitter. This is actually equal to beta times IB. This is your IB. This is your IE. And there's further some R0 also is there. And this is your collector. Okay. So in this circuit, this current, the current which is flowing over here is a function of IB. This beta times IB. Or it is not clear or something. Make it a bit off and right again. This is actually beta, okay? So this current, so this is your current IB, and this current over here in this branch is beta times IB. So this is a form of, is this a current source or voltage source?
Current
Current source.
This is a
current source.
source, and it is actually a current controlled current source. Okay. There is a current which is controlling it, right? IB is the current which is controlling it. So that it is a current controlled current source. This is for a BJT. Now we also have mutually coupled coils. So in mutually coupled coils, will it be a current source or a voltage source will be formed?
Voltage source.
Voltage source. Why?
EMF is induced
Yes.
due to the method of electromagnetic induction.
EMF is induced. So it is actually voltage. Okay. So that time it is a current controlled voltage source. The voltage induced is dependent on the current, right? Okay. So like that, there are many practical circuits where you have these sort of voltage sources and current sources are there. So now we will try to solve some sums, some assignment sums. We will look into it. Till now, anyone has any doubt, any query?
No, sir.
Okay, and from previous weeks, any query?
No, sir.
No, sir. Fine. So we will solve this sum. Okay. So how many independent voltage sources are here?
2.
Okay, there's a 15-volt voltage source and a 30-volt voltage source. And how many dependent sources are here?
1, sir.
So there's a voltage controlled voltage source. No, there's a current controlled voltage source. Okay, it is controlled by a current, the voltage. Okay, so now we want, what does the question say? They want us to find I1, then they want us to find I2, then they I1 and I2 we have to find. Okay. So, which is the easiest way, according to you, to solve this sum? Should I do mesh analysis or should I do nodal analysis?
Nodal.
Nodal analysis. Okay, so this is my reference node. This is my node. Let me call this node Vx. So let us start. So nodal analysis. So how will we write KCL here?
Vx minus 20 I2 minus 15 divided by 25 plus
minus 20 I2 minus
15
acha minus 15
divided by 25.
Okay.
Vx by 20 plus Vx by 20
Okay.
plus Vx minus 30 divided by 15
Okay.
is equals to 0.
Okay. So is it correct?
We substitute I2 is equals to Vx minus 30 divided by 15 here.
Okay, that also we can do. But
We have to.
my query is, there is a mistake over here. What is the mistake?
Plus 20 I2.
Yes, it will be plus 28, right? Okay. So this is Vx plus 20 I2 minus 15 by 25 plus Vx upon 20 plus Vx minus 30 upon 15. Now you are telling to substitute I2 as I2 is what?
I2 is minus of Vx minus 30 divided by 15. That will be 30 minus Vx by 15.
Okay. Acha, this is I2. Okay. So now, so only I2 we have to substitute, right? Okay. So we have Vx plus 20. I2 is what? 30 minus Vx upon 15. This is minus 15 upon 25 plus Vx upon 20 plus Vx minus 30 upon 15 is equal to 0. Okay. So this actually becomes equal to 4 by 3. So this actually is Vx plus 4 into 30 minus Vx upon 3 minus 15 upon 25 plus Vx upon 20 plus Vx minus 30 upon 15 is equal to 0. Okay. Let me multiply by 5. Okay, let me first rationalize. So this is not yet in a proper numerator denominator form. So I multiply throughout by 3. So it becomes 3Vx plus 4 into 30 minus Vx. Okay. Minus 15 into 3 divided by 3 into 25 plus Vx upon 20 plus Vx minus 30 upon 15 is equal to 0. Any queries in this?
No, sir.
Okay, so this becomes 3Vx plus 120 minus 4Vx minus 45 divided by 3 into 25 plus Vx upon 20 plus Vx minus 30 upon 15 is equal to 0. Okay, so it becomes equal to, what is 120 minus 45?
75.
75.
75 minus Vx upon 3 into 25 plus Vx upon 20 plus Vx minus 30 upon 15 is equal to 0. So what do we do now? We have to get a common denominator. Anything common in your denominator?
5.
5. So what I do is I multiply both sides by 5. So what happens when I do that is it becomes 5 into 75 minus Vx upon 3 into 25 plus 5 into Vx upon 20 plus 5 into Vx minus 30 upon 15 is equal to 5 into 0. So this becomes 75 minus Vx. 5 here 25 is actually 5 into 5. So this becomes 3 into 5 plus Vx upon 20 divided by 5 is 4. So Vx upon 4 plus Vx minus 30 upon 3. This is equal to 0. Okay. Till here everything is clear.
Yes, sir.
And then here I see 3 and 3 common. So what I will do is I will write 75 minus Vx upon 3 into 5 plus I have to multiply by 5 here. So I have to make it 5 into Vx minus 30 upon 3 into 5 plus Vx upon 4 is equal to 0. So this becomes 75 minus Vx plus 5 Vx minus 150 upon 15 plus Vx upon 4 is equal to 0. So this becomes 4 Vx minus 75 upon 15 plus Vx upon 4 is equal to 0. Now what should I do then?
Okay, sir.
Hmm?
Take the LCM.
Okay, so I do my cross multiplication. So it becomes 4 into 4 Vx minus 75 plus 15 into Vx upon 15 into 4 is equal to 0. So this becomes equal to 16 Vx. What is 75 into 4?
300.
300.
300 plus 15 Vx is equal to 0 into 60, that is equal to 0. So I will get 15 Vx plus 16 Vx is 31 Vx minus 300 is equal to 0. So what is Vx?
300 by 31.
How much is that?
9 point something.
Sorry?
9.677.
So this becomes 9.677 volt. Okay. So now what is your I1? What is I1 equal to?
Minus of Vx plus 20 I2. Before that, first we have to calculate I2.
Okay. So what is I2?
So it will be
I2 is actually
I2 is 30 minus Vx by 15.
okay. I2 is 30 minus Vx by 15. So how much is that?
$10.33.
Huh?
Sorry, sir. Sorry.
No one else is calculating. Only she is going to do.
Minus 7.67.
How? What about Hota? What about Akash? What about Narasimha? What about Bharat?
I forget the Vx value.
हाँ
अब Vx का वैल्यू भूल गया.
अच्छा Vx का वैल्यू है आपका Vx का वैल्यू है 1 मिनट 9.
9.677.
Vx is 9.677.
1.35.
1.35. Yeah, it is 1.35 ampere. Kavya, what is it? You're getting it wrong. So your I2 comes out to be 1.35 ampere. Okay. Now what will be your I1?
Vx plus
Hmm?
20 minus 15 by 25.
Yeah, I1 is what?
Vx plus 20 minus 15 by 25.
V1, I1 you're saying is Vx minus 20 I2
Plus 20
plus 20.
minus 15 by 25.
Acha. Okay.
Will be minus of that value, sir.
It will be
Minus.
yes, because this is what you are saying. Hota, you are saying Vx plus 20 I2 minus 15 is current in this direction, but your I1 is in the opposite direction. Okay. So this into minus 1. So what is this value?
Minus 0.87092.
Okay. Others also got the same answer, or only Kavya is solving?
Yes, sir.
Okay. Just 1 minute. Okay, so your I1 is minus 0.8709, sorry, and your I2 is actually 1.35 ampere. So if there are no other queries, then we can proceed to the next question. But I'd say in this question, it would have been easier to solve it using mesh analysis. This way, it really went all long. So this time it was difficult. The issue is because you have this 20 ohm I2 over here. Okay, that is making complicated where you're again resubstitute in your first equation. Instead, if you just do simple KVL of both the measures, you will get equations in terms of I1, I2. You will get two equations in terms of I1, I2. Then also you'll have to substitute. But I think that would have been the easier way. Okay. So can anyone tell me why it is written 20 ohm I2 over here?
Since it is a voltage.
Because I2 that 30 volts is supplying the power. Hence it is dependent on that. So.
Yeah, but why did we add ohm? Someone else saying something else?
It's a voltage source, so there is a current dependency, so it must be having some resistance also.
So it is just to match the dimension. Okay. Because your voltage is your ohm into ampere, right? So to match those dimension, we give 20 ohm I2. You know that. Okay. So you're actually multiplying it by some sort of resistive gain. So now we'll go to the next question. So when there are dependent sources, what happens to the various network theorems you have studied? Can it still be applied? Hmm? Can you still apply your various theorems which you studied, such as superposition theorem, Norton's theorem, Thevenin's theorem, and all?
Yes, sir. Yes, sir. Yes, sir.
You can still apply, right? So if I want to apply over here,
Yes, sir.
if I want to apply a superposition theorem, what should I do? Hmm? What happened to everyone?
They're just asking in common.
There is one source.
Ah. So there's no need
So
to
why
apply.
were applying as
Ah, yes.
superposition?
Okay, if there are multiple sources, then what you do?
If more than two sources, if the more than two independent sources, then we can apply superposition theorem.
Okay, assume there's some voltage source over here. Okay. In this case, how will you apply superposition theorem?
First, consider the 12-volt source by replacing the 2-volt source by short circuit.
Okay.
And the dependent sources are as usual.
Okay.
Yes, in step 2, consider the 3-volt source by replacing the 12-volt source by short circuit.
What do you mean 12-volt source? There's no 12-volt here. There's 2-volt.
2 volt, 2 volt, sir, 2 volt. Yes, sir, 2 volt.
Okay. But your these dependent
Sir,
sources.
by applying sir, while applying superposition theorem, if there are dependent sources, they are considered like resistors or it will be kept. They will be not nullified. And
Yeah,
if there is only one source, that it will be considered and it will be solved.
Okay, yeah.
If there are two independent sources, considering one independent source at a time, we will solve the equation.
Okay.
Dependent will be kept as it is in the both the cases, in both the two independent sources.
Yeah. Okay. So now, suppose you want to solve this circuit using Thevenin's theorem. You want to find the Thevenin's voltage. So what will you do then? How will you solve it?
Sir, V1 is the Thevenin's voltage. Yes, sorry, V1 plus 7I1 in
Yes.
outer loop. Right side loop में by applying the KVL in right side loop, we get the VAB. That is in VTH.
Okay.
Sir,
Alright.
we have to take one voltage source at the output side and do it.
No. Thevenin voltage you want to find,
No,
right?
no, sir.
Right.
Yes, sir.
So
By
open
applying the KVL in outer loop, voltage across the 2 ohm resistance and 7I1 drop. If we apply the KVL, then we get the Thevenin's voltage, VAB.
you apply KVL and tell
First, we find the current across 2 ohm resistance.
Okay. You have to find a current across the 3 ohm resistance.
2 ohm resistance.
3 ohm, right?
2 ohm, sir.
You want to find a voltage across the 2 ohm resistor and the current through the 3 ohm resistor. You need to find, right?
Yes, sir. Yes, sir.
Okay. So now this is open circuit. Okay, this is open circuit. So what will be the current going over here?
0 ampere.
So this current is 0 ampere, right? So now if I apply KCL over here, what will I get? Or okay, first before that.
V1.
I1 equal to 0.
Sorry.
Sir, the current across 2 ohm will be
Incoming is
I1
I1.
minus V1 by 2. That will be
That
I1
current is
minus.
0.
Okay. So let me go step by step. So we apply KCL, right? So we apply KCL. The current coming in is I1. And the current going out is your V1 upon 2 plus V1 upon 2, right?
Right.
So you get your, so this implies your I1 is equal to V1. In this situation.
Yes, sir.
Okay. Now, what is your I1 but in your circuit? What is your I1?
V1 minus 2 by 3.
2 minus V1 by 3.
This 2 minus V1 by 3, right? So now we will solve it. I1 is 2 minus V1 upon 3 and I1 is equal to V1. And so we put here V1 is equal to 2 minus V1 upon 3. So I get 3 V1 is equal to 2 minus V1. So what will I get? How much will be V1 then?
1 by 2.
Okay. So my V1 will be 1 by 2. That is 0.5 volt. Okay.
And how?
3
V1.
Because it becomes 4 V1 upon 2, right? 4 V1 is equal to 2. So this means your V1 is 2 by 4, just 0.5 volt.
Yes, sir.
What is your I1 then?
0.5 amperes.
Your I1 is 0.5 ampere. Now what do we have to find? We have to find VTH. Okay. So to find VTH, what we will do?
Applying the KVL.
Okay, so apply KVL.
Plot V1 minus 7 into I1 minus VTH equal to 0.
V1 minus 7.
Minus 7 I1
Minus VTH.
minus VTH equal to 0.
So VTH is equal to V1 minus 7 I1.
0.5.
How much is this?
Minus 2.5. Sorry, minus 3.
Minus 3 volts. Okay. Yeah. So in this circuit, there were how many dependent sources were there?
2.
2 dependent source.
And like one was dependent on voltage, another was dependent on current. So the dimension factor is there, that ohm is there. But when you're doing numeric calculation, you don't need to consider that ohm. So now we have done, we have found a Thevenin voltage. Now we want to find a Norton's current. Okay, so we have to find a Norton's current. So this actually is a Zoom meeting. So it will end in like 1 or 2 minutes and then I'll again restart the meeting. Okay. So now for Norton's current, what should we do?
Or circuit the AV terminal.
Okay, so I short circuited it. And what will be the direction of the current?
A to B.
A to B. So this is my short circuit current. Okay. Now how will I solve this now? Which method I must use to solve this?
Sir, KCL.
We apply KCL where?
node V1,
Maybe
node V1.
we can apply that V1 is equal to 7I1. 7I1 minus 2 by 3 is equal to I1. So we'll be having only one equation.
Okay. Okay. So you're saying we apply, I1 is actually equal to 2 minus V1 upon 3, right? So your I1 is actually 2 minus 7 I1 upon 3.
3.
So what do we
we'll
get then?
get I1. 10 I1 is equal to 2, I1 is equal to 0.2.
So you got I1 is equal to 0.2 ampere. Then what will be your V1 then?
0.3, 7I1, sorry.
That is how
So
much?
it is 1.4.
So this is 1.4 volt. Then what is your ISC?
That is equivalent to I. Oh, sorry. So we have how much?
So now we have found V1, we have found I1. So how will I find ISC? I short circuit current. What happened? Suresh,
Sir, applying KCL
KCL, where I'll apply KCL?
across the node V1.
Oh, okay. So we'll apply KCL then. Okay, what will be the equation then?
V1 minus 2 by 3 plus V1 by 2 plus V1 by 2
3 plus V1 by 2 plus V1 by 2
plus ISC equal to 0.
plus ISC is equal to 0. Okay. Then,
Yes, sir. Now we get the value of V1 by putting the value of V1,
so what is the value of V1?
1.4
Okay, so we can write this further as ISC is equal to minus of V1 minus 2 upon 3 minus V1, right? So it will be minus of 1.4 minus 2 divided by 3 minus 1.4. So how much is this?
Minus 1.6.
Minus 1.6. No, it's 0.6. No, it is actually because minus of minus 0.6 upon 3 minus 1.4. So it is 0.6 upon 3 minus 1.4. 0.2 minus 1.4. So ISC comes out to be equal to minus 1.2 ampere, right?
minus 1.2 ampere.
Yeah. Okay. So now we want to finally find the Thevenin's resistance. So how will we find the Thevenin's resistance?
VTH by ISC.
Yes, so the very easy method to find the Thevenin's resistance VTH upon ISC. How much is VTH
minus 3
and how much is ISC?
minus 1.2
So how much is my RTH?
minus 2.5. Sorry, 2.5 ohm.
2.5 ohm. Okay. So you must take care of the signs.
Yes, sir. Minus cancel. 2.5 ohm.
Okay. Okay. So actually all these meetings I will be uploading on YouTube. And also these notes I will be uploading on YouTube. So I will share the link with you guys. Meeting link. So I've sent it on the chat. Are you guys able to see it?
Yes, sir.
Okay. So we'll proceed to the next question. So right now, what are you guys solving in the assignments actually?
Yes, sir.
No, which assignment you guys are submitting now?
9, week 9.
Assignment 8, week 9.
Assignment 8, week 9.
Assignment 9, sir. 8 is already submitted.
So assignment 9, when do you need to submit it?
27.
Wednesday.
27, Wednesday.
Okay, okay. And one more thing, when is your
Tomorrow.
main exam?
Huh?
When is your NPTEL
April
exam?
21. April 21.
Oh, okay. April 21. That is Sunday.
Yes, sir.
Okay, so actually I don't know, like, how do you guys get, what you mean? Your center or?
In local town, sir. In
Oh,
our state.
in your state only. Acha, and what about what is what I was able to say? So you have only one day in which you have to solve. You have to give this exam,
Yes, sir.
and you have also. How many of you have registered for it?
Sir, I was already registered.
Who has
I
not?
have also.
Okay, Akash, you have registered.
Yes, sir. I have registered.
Okay, Suresh has done. Ota, have you registered?
Yes, sir. Yes, sir. Yes, sir. Registered.
Okay, and Bharat, Kavya, Narasimha.
Yes, sir, registered.
Okay, okay. What about Bharat? Bharat is not telling. Keep it a secret. Huh? Okay, so yeah, we'll go to next question. Okay, and I will also be conducting a summary session. Summary session also I'll be conducting on. I'll be conducting it on Thursday, 18th April. Okay, so that summary session will
Yes,
be
sir.
like normally I have these sessions on Tuesday, and but that will be so Tuesday also I'll have a session for week 12. And on Thursday, I will have a summary session. So, which topic are you guys really struggling or want more, want me to focus on or something?
That we can decide on the 12th one.
Okay, on the 12th one. Okay. But till now, like everything is smooth.
No, sir.
Yes, sir.
There are some more problems on week 2 and 3.
On week?
Week 2,
2 and
3.
3.
Oh, week 2 and
The
3.
transient current answer. Yeah. Before applying that, the conventional method we just solved, right? There we are.
Convolution method.
No, conventional method. Before.
Okay. Okay. Before
Yeah.
Laplace transform, the conventional method to solve
Yeah.
that one.
Yes, sir.
Okay. So that you want to focus. Yeah. Then what about these mutual coils? All that? Because I find it difficult. The mutually coupled coils.
It's a little bit on IC circuits.
little bit on which
If we understand how to solve the questions on week 2, 3, it will be easy, sir.
Okay. So
That mutual it will be easy.
okay, that I'll do. Okay, and someone was saying some IC circuit.
AC circuits, like little bit about mutual coils, right? That was.
Oh no, I'm sorry, I didn't get you. Which circuits you are talking about?
Sir, it's around week.
AC circuits, right? That phasor
AC
diagrams looks
circuits.
like.
Yes, phasor diagrams.
Okay, the AC circuit phasor diagram. Okay. So one thing is you guys want is conventional method to solve differential equations, right? This is one. And the next one, you guys want is AC circuits, right? Okay. Then I'm missing anything? Or this is fine, right? Okay. So this you have to do the summary session. So the summary session will be a 1 hour. So as much as possible, I'll try to cover. Okay. It'll be mostly problem solving. Go to this question. Okay. So how do you solve this question?
Maybe we can use that 0.4 into I is voltage across the resistor.
Okay.
And we can apply that KCL at that node and we'll get I value.
Okay, so tell how to do.
0.4 I minus 20, 20 minus 0.4 I divided by
20
R1
plus 20. Okay, 20 minus.
Yes, 0.4 I.
No,
Sir,
but that,
0.4 I is the current source.
no.
That is the current source. Take a node voltage.
This is not voltage.
Yes, sir.
Sir, I plus 0.4 I is equals to 28 amperes. It is given. I we can.
It is given.
The thing is we just apply KCL. I have I plus 0.4 I is equal to 28. So what is my I?
10 amperes.
1.4 I equal to 20.
20
28
amperes.
divided
I
by
equal to
1.4.
1.4.
How much is that?
280 by 14.
20 amperes.
20 ampere.
Yes, 20. Okay. So I got my I. What
Yes, sir.
still let me check. They ask this, then they want to find the power supplied by the independent source in what? So what will be the power supplied by this independent source?
20 into I.
20 into I. How much is that?
400 watt.
400 watt. Okay. Then we'll go to the next question. Okay. So in this one, we have to find power supply generated. Okay. Just power supply. Fine. So if we have to find what is the power given generated by this 20 volt voltage source, what is the power delivered or supplied by this current source, and power delivered or supplied by this source, as well as the power dissipated by this resistor. You have to find that out. Okay. So how should we start? So if we want to find the power being generated by one source or being delivered by another source, and the power dissipated in the resistor, for all these things, so first we need to solve the circuit, right? So how will you solve the circuit?
V1 is equal to V2, that is equal to 20.
Then we will get I2, so V2 divided by 2.
I2 is equal to V2 divided by 2. That is
10 amperes. 10 amperes.
okay.
V4 is equal to V5 similarly.
V4 is equal to V5. Okay.
Sir, then I3 is equals to 8 V1. We know V1.
8 over V1. Okay, 8 V1. So 8 into V1 is how much?
160.
160.
160 ampere. Fine. Then
Sir, if I3 is 160, that we know that I1 is equals to I2 plus I3.
we know I1 is equal to I2 plus I3. What is my I2?
10 amperes.
10 ampere.
I3?
160.
Okay. So my
Then
I1
we can calculate power delivered by this 20 volt source.
Okay. How much is the
We
power
know
delivered?
V1, I1.
3400.
3,400 watt.
Yes.
3,400 watts. Okay. So it is how many kilowatt?
3.4.
3.4 kilowatt. Okay. Next.
Sir, V4 is equals to 2I2. We know I2, sir.
How much is I2?
10.
I2 is 10, sir.
20 volt.
That is 20 volts. Okay.
Therefore, V5 is equals to 20 volts, same. Sir. V4 equal to V5.
Okay. Then
Now we know we can calculate I5, sir.
how much is it?
V5 divided by 5. 20 divided by 4.
4 amperes.
Okay. Then
Power we can
Sir,
consume with
I4 is equals to I3 minus I5.
okay. I4 is equal to I3 minus I4. What is I3?
160.
160
Okay.
plus 4, 156.
It is I3 minus I5, right?
Yes, sir.
So that is 156 ampere. Okay. Then
Now power delivered or supplied, it can be calculated. We know I3 and I4.
okay, what is the power delivered by this current source?
Voltage across it is 0.
Okay.
So P is equal to V into I. So whatsoever the consumed or delivered is 0.
The voltage across the current source is V2 minus V5. Okay. That is equal to 20 minus 20. That is equal to 0 volt. So the power delivered is voltage across the current source into I3. That is 0 into 160. That is 0 watt. Okay. Fine. Now, what is the power delivered by this voltage source?
V4 into minus I4.
Why minus?
Oh, I mean, it is absorbing
It's
power, right?
consuming
So
power, sir.
consuming power.
So now let us consider delivering power. So how much power is it delivering?
For that, we need to put a minus sign.
Okay. So delivering power, voltage source, power delivered is V4 into minus I4. What is your V4?
20.
What is your I4?
156, I
156
guess.
Okay. So how much is total power?
minus 3.12 kilowatts.
Okay, then minus 3120 watts. Okay. Now tell me how much is the power consumed by this 5 ohm resistor and 2 ohm resistor.
20 into 5, 100 watt
Okay.
by the 5 ohm.
Okay.
Sir, or 3.4 minus 3.12.
Sorry. What did you say? 3.4.
Total power is 3.4 kilowatts. Power delivered by 20 volts.
Okay.
Then the power that current source power will be it is zero, sir.
Okay.
So this dependent to voltage source power we have calculated it as 3.12 kilowatts.
Okay.
Then we can minus this and we will be getting the power across both the resistors.
Okay. Okay, that is one way.
Simply, simple way is V multiplied by I value. We know all current values and all voltage values.
Okay, we will check. So power delivered or consumed by the resistors is I5 square into 5 plus I2 square into 2. I5 yours is 4 square into 5. I2 square is 10 square into 2. So this is 16 into 5 plus 100 into 2. That is 80 plus 200. That is equal to 280 watt. Any queries in this? Also, I'll ask Kavya was saying, your power delivered by your 20 volt thing is equal to the power consumed by your current source plus power consumed by a voltage source plus power dissipated across your resistors. So this actually is equal to 3400. Power consumed by a current source is actually minus of minus, so it is plus 3120 watt. So no, across the current source it is 0, across voltage source it is 3120 watt, across your resistor it is 280. Okay, this way also you can solve.
Convention.
Huh?
Conservation of energy or power.
Okay. Yeah. So this is done. So no queries you guys have? Because I'm surprised because we have finished solving the sums. So I'll have to take your doubts, Sunil. Whatever doubts you have, whichever topics you have. So all of you are doing electrical engineering?
Sir, electronics, communication,
Electronics. Oh, in which year? Which semester?
final semester.
Okay. So what project are you doing?
Sir, based on phase lock loop.
Oh, phase lock loop. So what are you doing in the phase lock loop exactly?
Like we are trying to reduce the phase noise and jitter.
Reduce the
Phase noise and jitter.
Okay. So you're doing it in simulation or you're having a practical setup and doing?
No, sir. We are doing it in simulation, like based on cadence, VLSM,
Oh,
trying
you
to
have
go
access,
to.
you got access to cadence also.
Yes, sir. Like in our college, we have the tool, so using it. So
Oh, okay, nice. So you're from electronics department, right then?
yes, sir.
Ah, mm, okay. That is very useful, very nice actually. Hmm. Yeah, so it's a group project or individual project?
It's a group project, sir.
Hmm. Okay. So when do you have to submit your project?
Sir, by May,
Ah, hmm.
so we have about 2 months. Like first we try to do with Verilog AMS, and then now started analog implementation.
Okay. No, but
So now,
PLL like you'll have a controller part and it'll have a actual circuit block. So the circuit block will be the analog part and your controller part will be the Verilog one, right?
so, like we are not doing any controller. So like entire whatever the PFD blocks that we are designing
Uh,
using different architectures, like using the, trying to do different architectures. DLL, like a delay lock loop,
okay.
that that concept we are trying to integrate.
Mm-hmm. Mm. Okay, nice. Mm.
Actually trying to replicate a thesis paper set.
Yeah.
So
This is very
then
useful to do actually. It will have all the detailed explanation and you can
so,
understand it actually. Mm.
and also NPTEL course was there based on PLLs that we referred
Oh,
a little bit.
okay. By which professor it is that NPTEL course?
Sir, Saurabh Saxena, IIT Madras.
Okay. Mhm.
Actually, I have a question.
Mm.
Have you taken that course previously? Narsimha or somebody who's taken?
No, it's available. No, it's available on YouTube. Just went through the course. That's it.
Okay, was it helpful for implementing this PLL?
Like we didn't know anything about the PLL. We understood everything. Like he explained.
Okay, thank you.
And what about others? Others are not doing projects.
Yes.
Hmm. What project are you doing, Hota?
So that in MPPT system, gray wolf optimization technique
Which like optimization technique for solar?
to track the maximum power. Yes, sir, optimization technique to track the maximum power from the solar cell.
Is it
GW technique, gray wolf optimization technique.
Grey Wolf?
Yes, sir, gray wolf optimization technique, GW technique.
Okay. So like you are considering partial shading everything.
Yes, sir.
Achha. And this GW technique you're implementing in which software?
Sir, doing MATLAB software, sir.
Okay. For that you're using some toolbox, anything or what?
Yes, sir.
Hmm.
Sir, also doing the simulating model and also writing the code.
Hmm. So simulating model of your PV cell and of your boost converter.
Yes, sir. Boost converter, PV cell, and the
Uh-huh.
GW MPPT
Block. Okay. The controller.
controller.
Okay.
Yes, sir.
It's. Hmm.
And also write the program.
Yeah. Okay. And how long is it taking to run? Like it's taking lots of time the program to run, or it is going fast?
Sir, it will take some time, sir. We are actually
No,
new to this.
uh, no. What I mean to say is,
Mm.
uh,
Sir, I am basically from the electrical branch. So when writing the codes, some difficulties arises, sir.
okay. Oh,
In simulation model, no problem is there, but when writing the codes, basic syntax is needed. So some problem we are facing.
Okay.
Yes, sir.
So then you will not be actually making it in the hardware and running it.
Yes, sir. In the final semester, sir, we are planning. Yes,
Okay.
hardware model.
But now final semester
Yes,
is
sir.
right.
Yes, sir. Sixth semester, sir.
Oh, you're in sixth semester now.
Yes,
Okay.
sir.
You have to submit in the eighth semester.
Yes, sir. Yes, sir. Yes, sir.
Okay, then you have lots of time, no?
Sir, in our BPP model in sixth semester, that there is this project number 1,
Okay.
project.
Okay.
So you can choose different projects for
Okay.
6 sem, 7 and 8 sem. And then also you continue one single project.
Oh, okay.
So
So
in this semester, we are doing the Simulink models and programming models. And in 8th semester, we are doing the hardware project.
Oh. Achha. Okay. Then who else is there? So Suresh, what are you doing? You're doing any project anything?
No, not it. Actually,
Okay. You're in your second year still.
third year.
Achha, your project only in your fourth year.
Yes.
And like what sort of topic are you inclined to choose as such?
I would like to choose VLSI related.
Okay,
So
so
in that,
huh?
the ASIC level, we would like to see it.
ASIC
ASIC level
is
implementation.
that very long one, right?
Yes, very large one. Yes.
Okay.
RTL.
RTL. You're from electronics background, right?
Yes, electronics, right.
So, achha, and so you learned very long
Yes.
from this the professor NPTEL course.
I did part of that, and on top of that, I have known of some people who are working in industry, so I learned from them as well.
Okay. Yeah, nice. So you'll be using which one? You'll be using Xilinx or Vivado. Which one you're planning to use?
Yes, Vivado we would like to. Yes.
Okay. Fine.
I mean, I did some prototypes in that Vivado. So some
Okay.
FPGA we have. So on that, some emulation kind of things we did already. We bought up some modules like basic modules, and I would like to extend this width to in a bigger level. That's what I would like to do it.
So till now, like what modules have you made till now?
Basic models like I2C we have done it,
Okay.
and some flash bits I have done that. SRAM read and writes I have done for the FPGA inside.
Okay. So my question is, I2C is like a protocol. So based on that protocol, you have written a block which will do the communication, sending and receiving, right?
Right. Yes.
Okay. So it has some.
Externally, we'll be having the device on device. We'll write from that particular module to the device, and then we'll read back the same to the device from the device.
Okay.
So that's how internally we have another interface which will be reading the data from the device what we have written.
Okay.
So this module will do both bi-directional. It will do.
And then you are saying after I2C, you are saying you are doing something else also, right?
Yeah. Inside we have memories, right? For the
Okay.
FPGA.
The memories you did. So these all you're planning for what application you're planning to do?
I would like to do some optimization kind of thing by using these modules. I
Yeah.
mean, we have the generic module, so I would like to implement integrated one which will support both I2C or small interfaces like DDR kind of.
Okay.
I would like to implement that the entire soft circuits, right? Instead of the hardware, that soft IP is standalone IP which can support all. most of the generic interfaces as a module.
The generic interfaces, you mean the various protocols you want to support, or like what?
Yes, multiple protocols.
So like what I understand is you want to have one hardware which is softwarely through software it can do I2C plus something else
Yes.
and something else.
Yeah, now there is a limitation on the hardware side. We'll be requiring different hardware devices to connect to different modules now, right?
Mhm.
But
Mhm.
I'll be keeping a one device which can automatically switch to different interfaces based on the registers that we are implementing inside the
Oh,
controls or GPU controls.
okay. Oh. Mhm. And you so like you're using which FPGA you're using?
I have done that Kintex 7 one, and I have also used Vertex as well.
Okay. Nice. Mhm. Nice, yeah, you guys are doing really interesting projects. Then who else is there? So Bharat, what project are you doing? Hmm. And Akash?
Sir, I'm currently in my. I just completed my third semester, so you know, I'm just
Mhm.
going through all the steps what can be done.
Okay. Nice. Okay. Yeah. Mm, that is there. I like to implement your projects like how do you guys work? Like you have some the projects are assigned to you or you guys come up with the topic?
It's bidirectional,
So,
right? For example, if we are interested towards one subject, then professors are allowing us to do that.
mhm.
If we are not interested in any subject, then they'll assign something to do it.
Okay. Hmm. All right. And none of you are like making PCBs or anything?
I did design also, schematic design for the few hardwares.
Oh, which software you used?
I use KiCad.
Oh, okay, okay. Uh, Open source one. Achha. So you just made the schematic, you didn't make the layout and everything.
Layout also I made it, but I didn't
Fabricate.
generate that as Gerbers. Yes, I
Okay.
haven't generated those Gerbers.
Okay. Achha.
But I know the DRCs and I know the design rules, so to implement them. So till that point we have done, but I haven't just printed out that.
Yeah. You have to send it to your fabrication house. They will make it. They will test it. Then they will send it to you. Then once that comes, then you'll
That
have
was
to.
like a that
So
was a 7 segment display. We have 7 segment display.
okay.
On that, we would like to count the timing.
Hmm.
So for that purpose, we did use one controller, and I have connected all these to the 7 segment, and then I have generated the schematic and the PCB as well. But I haven't gerbered out that.
Hmm. Okay. Achha.
I,
Then
I have simulated that in software, Proteus.
oh, you can simulate that schematic itself in the Proteus.
Yes, we can simulate that
No,
Proteus.
like you can either separately make it in Proteus the schematic and then simulate, or you can directly import the KiCad schematic and simulate in Proteus.
No. For KiCad purpose, both sides schematic is same, but I have would like to check that whether it is working fine or not. That's why I have generated another schematic in the Proteus.
Ah,
I haven't imported it. I haven't imported it.
yes, that was my question. Because that would be useful if you can just have a schematic in KiCad and directly import it into one solver or some simulator and then check whether it is working as you want and all. Because you might.
I'm also interested in towards the schematic and PCB design also,
Mhm.
but they are not allowing us to do this PCB manufacturing kind of. It will take some turnaround time, so that's why they are not allowing us to do. So that is the reason why I'm moving to VLSI.
Oh. Okay.
Sir, can you sir solve the question number 1 with KVL loop analysis?
This one.
Yes, sir. Question number 1, first question.
Okay. I'll solve that. Okay. One minute. I'll just discuss with
With
Suresh.
KVL.
Okay. So Suresh, so you guys you were not planning to go for PCB. You're not able to go for PCBs.
Because of the support that we are getting is minimal. If somebody is interested towards the PCB, then the management is asking us to buy something and then do work on it. We don't want to do that.
You have to buy what?
The existing PCBs, right? Available some kits, kits will be there, right?
Okay.
Hardware kits.
Okay.
So they are asking us to buy them and then work upon some software related things.
Acha. Okay. Oh.
But that is not that interesting.
Yeah. It is already built. Someone has already made it. Yeah. Okay, so we'll solve this question through KVL, right? 1 minute. Okay, this here. So I have to apply KVL. Okay, so I do mesh analysis. So this is my I1. This is my I2. So
More easy, sir.
so let me apply KVL in loop 2. So what I will get? 30 minus
Plus 30 minus 15 into I2 minus 20 into I1 plus I2 is equal to 0.
Okay, so I get 30 is equal to 15 I2 plus 20 I2 plus 20 I1, or write it as 20 I1 plus 35 I2 is equal to 30.
Yes, sir.
So I write it down as, so I divide it by 5. So I write it down as 4 I1 plus 7 I2 is equal to 6. This is my equation 1.
Yes, sir.
Now I apply KVL in mesh 1.
Yes, sir. It is very simple.
So I will get 15 minus 20 I2 minus 20 of I1 plus I2.
Minus 20 I1 plus I2 minus 25 I1.
15
equal to 0.
minus 20 of
Minus
I1
20
plus I2
I1 plus I2 minus 25 I1
is equal to 0.
equal to 0.
So we
Yes,
get
sir.
is equal to 20 I2 plus 20 into I1 plus I2 plus 25 into I1. So we get 45 I1 plus 40 I2 is
Equal
equal
to
to
15.
So now you divide this also by 5. So you get 9 I1
No.
8
8 I2
is equal to
equal
3.
to 3.
Okay. Now how will you solve both these equations?
By Cramer's rule or by calculator?
Okay, what I did was you could instead you could do 9 I1. No, what I did was this is actually equal to 6, right? Which is actually 2 into 3, right? So I wrote 4 I1 plus 7 I2 is equal to 2 into 3. And what is 3? My 3 is 9 I1 plus 8 I2. So this is 9 I1 plus 8 I2, right? So this comes out to be 4 I1 plus 7 I2 is equal to 18 I1 plus 16 I2. So you get minus 14 I1 is equal to 9 I2. So I1 is equal to minus 9 upon 14 I2. Okay. Any doubts in this?
No, sir.
So I put this in equation 2. So I get 9 into minus 9 upon 14 I2 plus 8 into I2 is equal to 3. So this comes out to be minus 81 I2 upon 14 plus 8 into I2 is equal to 3. So this is actually minus 81 plus 14 into 8 I2 upon 14 is equal to 3. So this is, what is 14 into 8 is how much?
112.
112 minus 81 upon 14 into I2 is equal to 3. So my I2 is equal to 3 into 14. 112 minus 81 is 1. 12 minus 8 is 41. So it is equal to
0.2.
3 into 14 divided by 41. That is 1.0243 ampere we get. No, this is 31. This is 31, sorry. So this will be equal to
It's 1.35.
1.35, 8 ampere. Okay. Similarly, what will I1? My I1 is equal to minus 9 upon 14 I2. It is minus 9 upon 14 into 1.358. How much is that? Hmm.
0.873 minus 0.873.
Okay. So this way, this method is much more easier to solve.
It's much more easier, sir. Yes, sir.
According to me, this is a much more easier method to solve. This question 1.
Yes, sir. Yes, sir.
Using question 1 only, we are solving it using mesh analysis. Okay. So here we
Yes,
can.
sir. Yes, sir.
So I'll just give a brief recap. So we have various circuits are there. It has battery. It has various sources are there. So a source can be as an independent voltage source or a dependent source. Okay, independent source, it maintains its voltage or current independent of the circuit conditions. While a dependent source depends either on the voltage or current at one particular branch or one particular node. And based on that, it will generate either voltage or current, right? So also there's an example of a BJT where your collector current is a function of your base current, and that is given in the small signal model of a BJT. It is shown by a current source. Okay, controlled current source. Similarly, for mutually coupled coils also, the current in one coil results in the generation of an EMF in another, in the next coil, in the coupled coil. So in that case also, it is a current controlled voltage source, and it's a voltage source because an EMF is induced. Now in this question, so this is a question which we solved. First we solved it using nodal analysis. Then it was very tedious. It became huge and huge and huge, etc. So it was a bit complicated. Then later on we solved it using mesh analysis. It was much more easier. All right. So in this case, we actually found Vx. We did not find I1 and I2. Did we find? Oh, we found I1. We found I1. We found I2 as well. So, but it took lots of time. So simpler method, as I said, you can just do mesh analysis. It would have been easier. So all of you are giving the exam. So you'll have to learn to do the calculations without being dependent too much on your scientific calculator. You must use the simple gate calculator. Okay. So I hope all of you have downloaded the gate calculator on your mobile. Oh, you guys have not.
Yes, sir. And there is a Chrome extension.
Okay. I not use the Chrome extension one. Okay, so you must use those calculators. Similarly, we have then in this sum we had to find a Thevenin voltage. We found a Thevenin voltage because although the dependent sources are there, we don't need to short them or open circuit them. We left them as it is in the circuit. Only the independent source voltage source we have to short it. Okay. Then we applied KCL. No. For this case, we didn't need to short anything. We didn't need to short anything. Sorry, because we are finding the open circuit voltage, so we didn't need to short anything. We just had to consider that the current flowing out would be 0 ampere. Based on that, we applied KCL, and then we found the various voltages. We found a Thevenin voltage. It came out to be minus 3 volt. Then we had to find a Norton's current. So for Norton's current, we just simply shorted the terminals AB, and again we applied KCL. Also we applied KVL. Okay, we applied it, and then we found a short circuit current is equal to minus 1.2 ampere. So then we found the Thevenin resistance is simple. We do the Thevenin voltage divided by the short circuit current, and that gives me my Thevenin resistance. Okay. Then in this sum, we should just apply KCL, very simple, and then we will get the current. And also we have to find a power supplied by this source. That is 20 into I, that is 400 watt. And then in this case, again, it is here they have given many labels are there, but there are two dependent sources and there's a single independent source. And we found out the currents and voltages across the different branches. After we found that out, we were able to compute the power delivered by this source, by these dependent sources, as well as the power consumed by the resistors. And we found that this independent source is generating the power, and that is being consumed by this current source is not consuming any power because the voltage across it is 0. But this dependent voltage source is consuming some power, and these resistors are dissipating some power. Okay. And that is the thing which we calculated. And then we again solved the first question applying KVL, doing mesh analysis, and it was much more easier to solve. All right. So any
I
queries?
have one doubt.
Yes.
Okay, in the last problem, and not this problem, because
Yes.
how did we find that V3 equals to 0?
Which one? V3. Okay. The voltage at over here. This is 20 volt. This also is 20 volt. So the potential difference is 0, right?
Yes, sir. But we did something V5, right? I don't understand that step. V5 minus V2 or V2 minus V2.
No. This V5 and V4 are equal, right?
Yeah, now I understand. Yes, sir.
This is like a common node, like the ground node. Okay.
I have a question, right? I mean, here the current source is neither delivering nor absorbing power, right?
Yeah.
But it is still contributing some current.
Yeah.
I mean, how it is possible without consuming any voltage, or it is acting as a voltage source? How can it deliver current? I mean, generally, voltage sources or current sources, either it can. Oh, you mean the consuming power is equal to the delivering power?
No. The deliver power means it is generating power. Consume
Yeah,
power
right.
means it is absorbing power. So here it is neither absorbing nor delivering power. Neither absorbing nor generating power.
But still we are having some current through that, right?
Yeah,
I mean, current is,
yes. Still there's some current, but since there's no voltage across it, the power, it's like basically a short circuit. Okay. It's basically a short circuit.
oh,
So
if it is like short circuited, then the current contributions like I1, I3, I4, I5 will have a different relationship, right? If it is
no,
a short circuited, because
it is not exactly a short circuit. It is like since the voltage across it is zero, and
okay.
it is found like in this network based on these particular value of resistors and all, the voltage is across it is coming to be zero. But in case you change the resistor value or change the voltage source value, the voltage across it may not be zero. And in that case, then it will consume power or it might be delivering power. Hmm.
It is not consuming any power or delivering. So I am thinking that the delivering power is equal to consuming. So that's why the net power is zero. That's what I'm thinking. If my
No.
understanding is different, correct. Okay.
Hmm. This is an ideal circuit. It's a very idealized version.
Hmm.
It won't be like this. Okay. And this is just fully resistors, everything. Actual circuit will not be like that. There'll be inductor, capacitor, and when there's inductor, capacitor, there'll be lag lead. Lag lead means there'll be overlap of voltage and current, and then there will be loss. Will happen. This is a very ideal circuit, and it could possibly be something might happen. Right? That it could that a condition could happen that the voltage across it could be zero. It could happen. Right? Hmm. Then, so none of you guys work on power electronics. Like, so many of you guys are working on VLSI. Is asking, no one is working on power electronics.
Sorry, sir. That is related to triple E.
Oh, you're double A. Okay. Mm-hmm. Bharat has gone. Kavya has come. So, Kavya, what are you working on? Which project?
Sir, on patients' health monitoring, we are developing a robot, sir.
Developing a robot.
Yes, sir.
So, what will the robot do actually?
It will monitor the patient's health, sir. Like it will check their vital parameters and informs to the doctor.
So, you're doing it in simulation or you'll be making the robot and everything?
We are implementing it, sir. Hardware projects.
Okay. And for implementation, what are you using?
Components so like Node MCU and the sensors.
Mm-hmm. Okay. So,
And
which
some PCB work is also there, sir, to develop it.
oh, so which sensors are you using?
Sir, we have plans, sir. Still, we have not implemented. We have planned to use heartbeat sensor, temperature sensor,
Hmm.
and pulse oximeters.
Okay. And what MC you're planning to use?
Sorry, sir.
What
Question I
MCU?
didn't.
Which MCU you're going to use? MCU, microcontroller, right?
Yes, Node MCU we are using, sir.
Node MCU.
ESP8266.
Which one?
ESP8266 Node MCU, sir.
Oh, okay. I'm not used it. Actually. So you are like you have got a broad idea, right? You need to your sensor is there. Okay. It will give you
Yes,
a
sir.
signal. It will give you a signal that is some voltage signal. Okay. That will go
Yes, sir.
to your MCU, right? This is
Yes, sir.
this is one pin of the MCU, and there should be an ADC. Hmm.
Yes, sir.
So the ADC, there's an external ADC or the ADC is inside your MCU.
It's inside the MCU, sir. We
Okay.
have digital pins on it. analog pins we have, sir.
You have analog pins. That is important. So you have analog
Yes.
pins. So you will send a sensor signal to an analog pin. Your sensor signal cannot go to your digital pin.
Yes, sir.
It will go to your analog pin. Your analog pin will convert it, and that you will use inside your MCU for determining whether the temperature is too high or your pulse is too low. All
Yes,
that.
sir.
Okay. So do you have a sensor? You have a EDC MCU. Then the output of the MCU will go to what? I mean to say,
Sir,
Mhm.
output of the MCU, the doctor will be able to see it, sir. That
Okay.
it will be connected to the cloud like this. Sir. Right.
Okay, so it will be going to your cloud or to your PC.
Yes, sir.
Acha, nice. Oh. Mhm. And then why do you need PCB then?
Sir, to power supply circuit and also and to implement these sensors and all in a single board.
Okay. That is okay. That I can understand. Then why do you need a robot then?
Sir, this it must be like a robot will go to every patient's bed and also we need robots.
Like a robot.
Motor circuit and all.
Like robot and all is all very complicated. No? You'll have to have these motors and control the wheels, which way
Yes,
to
sir.
position sensor. Those things are there. Okay. So you're doing which part then?
Sir, as a team, we are doing it. Sir. Which part like this we have not.
Okay.
We have to do all and implement it. Sir.
By when? By May?
Yes, by May end or June end, the last demo will final it will be.
Oh. Acha. Then you don't have much time, no? March is almost over.
Yes. Yes, sir.
Okay. So finding the robot and making robot, according to me, will take too much time. It will be quite hectic. You can do the sensor part and show it's working, then that would be something you have to show. You can have to show like that.
Yes, sir.
But are you facing any difficulties in this? Or you guys have not started? Or what?
Sir, robot we have not started it, sir. But this, like what you said, it is easy part that we have started.
So you're able to check
Robot,
this.
yes, sir.
So you know the sensors are working, everything, you tested it.
Yes, sir.
Okay. Sure. Nice. Then yeah. And which cloud you'll be sending it to? And how will you be sending it to the cloud?
Sir, that node MCU it will be it works. It has a Wi-Fi module in it, sir.
Oh, okay. So from that directly you send it to cloud.
Yes,
Okay.
sir.
Mhm. And for the node MCU, which software you using?
Arduino ID it is compatible, sir.
Okay. So with Arduino ID, you're using that green color one. Okay. All the best then. Then anyone has any doubts, any queries, any questions?
Not related to the subject, but where do I get? I'm just in my third semester. I didn't really understand what you guys spoke for last.
Where do we what?
I just no. I'm just. I mean, I don't know what you guys spoke now, right? I'm just very new to this. I just learned some basics. So we'll just learn by the flow, or we should learn something other than what the subject teach, something like that.
Mm, Okay, so one thing you must learn, remember, you cannot learn everything.
Yeah,
That is not possible to learn everything. And if you get brief exposure to, like, you use a microcontroller, one microcontroller you just implement some basic things, you get an idea of it, hang of it. Then some other thing you implement, some sort of filter you implement, other things. Basically, you get some sort of understanding of each and every block. I will basically get the foundations clear. Right, you have the foundation of how it should be done, what should be done. Then when you're working on your project, then you can go deep into some particular topic and you can make a project based on that.
Yeah, any source that I can just refer to, because I'm just new, right? I don't know anything in this. I'm
Related
just asking you guys.
to this microcontroller.
No, I'm just basically asking. I don't even know where do I have interest in.
Okay, interest.
Yeah, I'm just starting, right? And I just know that.
No,
Basically,
you're working on cadence, right?
Sorry.
You're working on cadence, right? Or you're the guy in second year.
Yeah, I'm going second year, third semester.
Okay, third semester. Why? It should be fourth semester now, no?
Yeah, third semester just got over, right?
Okay.
I didn't even.
Okay. So at this stage, fourth semester and all, you can do simulations. Simulations you can do, like, many times students are not interested in electrical engineering. They have got it by jabardasti, that no other option, so they got electrical engineering or something, and they don't pay attention in class, everything. But if you really like it,
I just took it my interest only.
okay.
Electrical engineering was chosen by my interest. I
Mhm.
was interested in the energy generation and stuff which I learned in my schools, right?
Okay.
The high voltage, all those things was really good to have. So I thought it would be nice to study electrical engineering. Moreover, everybody said it was tough.
Okay. So, if you are like, you see, you learn many things in electrical engineering. You learn about machines, you learn about motors, you will learn about these power systems, you will learn about this electronics also, and all these. So one way to to actually understand what you learn is to do simulations. Okay, you can do simulations. So you have MATLAB, right? So you
Yes,
can
sir.
use MATLAB to simulate what you learned. Suppose you learned like you learned about a DC motor. Okay, so you can open the
Yeah.
DC motor model in Simulink. Then you can give it some particular some voltage input source. You put some voltage source. You put. Then you also connect some load torque. You connect. Okay. Then you can, like, try to generate the speed torque curves, everything. So all these things usually it happens in your practicals. In your practicals, you have to do
Yeah.
simulation. Right?
And machines actually we don't have that simulation software and all. We just have to do it manually.
Okay.
But for network analysis, there was a simulation software.
Which one?
But yeah, they use Tinkercad actually.
Oh, okay. Tinkercad. Acha.
Just some basics, right? So they just use Tinkercad.
Hmm.
Moreover, it was like, अरे वही value डाल दो यार, तो फिर
It was what? Moreover, it was what?
we just calculate some value and then we simulate it, right? And then
Oh,
it was to manually do the calculations and then also simulate the values and compare those values. They just say that you just write these values and that values, just a point two or something, you just make the difference in between them.
oh. That's right.
Yeah, that happened. So that it didn't even touch the simulation software.
Okay. Yeah, that happens. You have to get results and show results, so that's the way you show.
Yeah, that's what.
So yeah.
So I was just wondering where to start and how to do these steps.
So this is like my way of looking at it. You will have to. You can try to learn some softwares like MATLAB, Simulink, and whatever softwares you guys have access to. Okay, whatever softwares you have access to, you can learn, and you can check online. The resources are there, how to learn them, and you can solve it for some things which you are doing in class. Okay, extra. Then one more
Yes.
thing is, if you see this high voltage generation or energy generation, these are very large scale things. This which is something you
Yeah,
cannot.
yeah.
So
Yeah. That's what I said. I just went to my professors and said, I am just interested in this. They said, "Pehle ye kar lo na." It's not like that.
Yeah. So those things you cannot do. You cannot do because it's too complicated. It's too big. You can start like these small DIY hobby projects. Okay, electronics, all those.
Yes, sir.
So those projects you can do. You can learn microcontroller. You can learn FPGA. Those are very interesting. Like you should see what resources are available in your college. Which are
Yes, sir.
like, are there setups available? Will they give you access and all?
Yes, sir. Access and all, they'll just give you no problem. But I just want to explore what are the things available. Now I just know 2, 3 names to ask my professors. They just don't come and say, right? Nobody will come and say, you want to go to ask them, then only they will just, yeah. That's what I asked. What are the things that I should talk to my professors about? And now I just got some ideas. These are the things.
Yeah, yeah. And like you're electrical or electronics? You're electrical, right?
Electrical.
Okay, so if you're electrical, like my way I look at it, you can learn a microcontroller. Like you can learn a microcontroller. Like you can see what and all are available in your department and everything. There's Arduino's there. Arduino's good. You can learn some things about Arduino. Further things, I don't remember the one I used in my BTech. I don't remember. So how to use an Arduino, how to run it, that could be a good starting point for you. And things which I really found interesting were like, filters. For me, I found filters very interesting. Like various sort of filters, like the filters which are there and digital filters also, etc. So those things I found interesting. And these things you can actually simulate them. You can simulate them and you can see. So filters are things you can simulate on software. And then later on you can implement in your Arduino or you can implement in your hardware also. Other thing is I had lots of interest in power electronics. This is something which I really liked. So this is power electronics is like you start with simulations and then you can also make a PCB and you can also use your MCU also. You will need to use MCU and a PCB and you can run it that way.
Yes, sir. Thank you. Actually,
and don't start very complex. Start with simple things.
Okay.
Because like when I teach students and all, you tell them you do this, they will make the complete thing and then they will start running it and check whether it's working or not. That is not the way to do. Like you suppose you have a microcontroller over here. Okay, you have a microcontroller and you have one signal is coming from here. So you first check whether you're getting that signal, whether that signal is going into your microcontroller, and then that same signal you use, send it to your computer, and you see that if you have given here 1 volt, whether the computer also is reading 1 volt. That is the first way to check. Then once you do that, then inside your MCU add one code that if it is 1 volt, it will generate 2 volt here. 2, it should read some value 2. Then if that is working, then if you see you give some sine wave or something, then you see whether computer also showing this one. Okay. Then you can add a filter. You can add a filter in your code that if it is like you have multiple frequencies, you have 50 hertz, 150 hertz, and you have a filter which will remove 150 hertz, then are you getting over here only 50 hertz frequency? So like that, you go step by step, you add everything. Okay. That
Yes,
way
sir.
it will become interesting.
Yes, sir.
Yeah.
Thank you.
Yes. Then anyone else has any suggestions for Akash? You guys are all big seniors, so tell him. Uta, Kavya, no suggestions. Suresh, huh?
Since he's in
Sir,
second year,
as you
right?
said, start with the simulation API, please.
Okay. And Suresh, you were saying something?
What I'm saying is maybe in the second year he can focus on the basic things, right? Which will be helpful for him to understand better when he's doing the simulations. What exactly it is coming. So when he sees something, then he should able to understand that why it is coming
It is coming.
and what effects are. Yeah.
Hmm.
So maybe simulations anytime we can ramp up. Maybe 6 months, 7 months we can ramp up. But the concept behind he should be able to understand. So maybe
Yeah.
in the second year he might be focusing on the core things where he would like to improve, or he would like to his interest, I would like to say his interest in his area. Once he established the strong foundation, maybe it will be easy for him to do the excel things.
Yeah. Okay. And one thing is you must do something where you'll get a job. Okay. It's not like that I'm interested in something, so I will only do that. And in case in that thing you don't get a job or very few companies come, then it is like pointless. Okay. So you have to balance interest plus something which is practically job oriented. Okay. So you
Okay.
go find out which companies come, what are the roles they are hiring for, what and all things they want you to have, and you do it.
Yeah, yes, sir.
That's one thing. And then if also gate preparation also you can start. Gate preparation also if you're interested in doing MTech or you're interested in going for PSU, that also you can start. That way. Yeah.
Yes, sir. Okay.
Yeah.
Thank you all.
So can I ask one question? I mean, whether it is, I mean, you can disclose or not, I don't know. But as a PMRF, in research point of view, what type of things that we are doing currently? I mean, you are working on related fields, like
Okay.
what R&D that you are.
No, mine is actually power electronics. I'm working on power electronics and
Oh,
computer.
okay.
So mine is a mixture. So I'll be using actually microcontrollers I'm using. FPGA I've had some brief interaction with it, but that is not the main thing I use. So I use a microcontroller and I'll be making PCBs and everything. So that is my thing which I'll be doing. Mine also is
Okay. So why am I?
okay. Sir.
Hey, why I'm asking this question is like in what direction that we are putting a focus in towards the research side. I want to understand. So that's the reason I am asking this question. I mean,
Oh,
we are keeping so much budget from the research, right? Research and development. We are keeping it. So I just want to understand what are the area of interest that we are putting in VLSI, or we are putting all mixed profiles or miscellaneous. How we would like to go ahead in future.
okay. So mine will not have much with VLSI. Mine is not much related to VLSI, my topic actually. Um,
Okay.
that could be you can make those controller VLSI ICs you can make, but that I don't have the expertise in that. So that is not what I'll be targeting. My target will be like these microcontroller based solutions for running these systems. This mine is basically power factor correction circuits. Yeah. So mine is like right now there's a lot of focus on the research related to electric vehicles. Okay, so electric vehicles they have this onboard chargers, everything. So at the front end part of that onboard charger is the power factor correction circuit. So I'm working on that part.
Okay.
Mm. And like many people are researching on how to make these control solutions are there, as well as VLSI is a very big topic right now. People are
Okay.
interested in that, like Indian semiconductors, how India can make its own ICs and everything. That also people are looking into it. So
Okay.
VLSI is a booming field, and yeah. So you're interested in analog VLSI or digital VLSI?
Digital VLSI.
Okay. Yeah, analog is the one which is very difficult. I've heard that.
Yeah, for that we need more basics and too much patience that we need to have.
Yeah, yeah, yeah.
That's what I heard from history,
Mm.
because all our calculations. I
Olaf?
mean, I have all are full of calculations and designs, right? So
Uh-huh.
we should have all the, I mean, I have few contacts in industry where the people are working in different fields. So I
Mm.
came to know that analog is difficult compared to with the digital. That is the toughest part. The
Digital is.
analog is,
Mm. Yeah, but you can
so
also
few people,
see because to what someone mentioned, like analog is something like no one can automate it, but digital is something which someone can automate it. So the guy
yes,
analog guy is started with
that
this.
is that is for sure.
Yeah, yeah. But it takes lot of
Because
time. It will take lots of time to learn the analog concepts. Like there are so many concepts, everything. So it will
see,
take lots of time.
each and every topic we need to learn in deep
Mm,
for analog design. So
mm,
it is like, so. I mean, I have seen people who are working in analog domain. They have been spending almost 18, 20 hours a day. Well, for peak times when they are taping out the projects, right? At that time, they will be spending 18, 20 hours almost. But
mm.
remaining times, on an average, they will be spending almost 12 hours a day.
Yeah, yeah,
So
yeah.
that is very difficult.
Yeah,
So
yeah.
for me, especially me, I am not strong in analog. That is for sure. I have very few basics for analog.
Mm.
Uh, so I'm feeling that I'm comfortable in digital. So that's why I would like to move to digital.
Okay, okay. Yeah. That's nice.
That's why I have started this digital concepts very early.
Okay. Acha, acha. Yeah, you can also digital is something you can test. Like analog is something you cannot test actually. It is just in your simulation unless you test it out.
Suggestions for
Uh-huh.
testing,
Sorry.
like testing for testing and verifications,
Uh-huh.
AMS verification and testing of
Uh-huh.
VLSI.
Yeah, yeah.
So any inputs for that,
Any
if you know.
mm, I don't know much actually, basically, because VLSI is not what I'm working on. I've just seen one or two guys doing it. So
But I have some idea about it.
okay.
So verification and design both are booming. That's what I heard from my seniors. So they told me that either verification or design both are good positions actually. And
Okay.
verification nowadays we are seeing down the line maybe 5, 10 years we'll be having exhaust number of openings. That's what I heard.
Okay. Mm. But design is, doesn't happen much in India, right? Design doesn't happen much in India. So what I,
So, design happens, but
but
design happens, but for freshers there are not much things
yeah, yeah. So,
usually to train
uh,
to train a lot.
so they will not give because the fresher doesn't know much, no. So that's there.
It's
No, yeah, that's there. So none of you are planning to do MTech.
Sir, actually, I cleared gate, but I don't know whether I can get into IITs. Like my rank is very low,
Mm-hmm.
like
Okay.
in 4 digits. So I'll
Mm.
try for another year doing job and then.
Okay. Okay. So your placement is done, like and all that. Placements are going on or not?
Yes, like yes, sir, I got recruited by company Tezol.
Mm-hmm.
My job profile was on verification and testing, so I asked about it.
Okay. 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 Yeah. Yeah. You're also electronics guy, right?
Yes, sir.
Mm. Yeah. You can work and you can try and check also how much you like it and everything. And you can also simultaneously prepare for gate and all. Yeah. That's yeah. Anything else?
Not from my side, sir. Thank you.
Okay.
Thank you very much.
Okay.
Yes,
Okay.
thanks a lot.
Hmm.
I learned a lot.
Yeah. Okay. Bye. Good night. Huh?
Thank you. Good night. Good night.
Thank you.
Yes. Thank you. Welcome.